Okay, now we've got to Chapter 2, Section 2, Addition and Subtraction of Whole Numbers. It says, number 1, addition may be thought of as joining two groups. Subtraction may be thought of as separating those groups. Um, addition and subtraction can be modeled. You can use pictures to model addition and subtraction. You can use joining or union of 2 or 3 sets or more. Example, A plus B plus C equals D. So that just says like all of this A plus B plus D, all of that is the same as D. So it's kind of joining the three. If the three, A, B, and C, if you add them together, it equals D. So the union of two sets A and B or three sets A and B and C is addition. So you're adding them together to equal the union. How is a union represented? It's A union B. And then number 5, disjoints. Disjoint sets are sets where the intersection is empty. So A disjointed with B is 0. All right, a way that we can represent this in like Venn diagrams, so it'd be kind of visual for you to see, is let's say if we have some circles. Want to duplicate. Let's duplicate it again. Let's move that one there. Duplicate this one. Duplicate, move that one over there. Okay, so we have, all right, let's see, number 6 is it says a complement of a set is A, all the elements in the universal set that are not in A. All right, let's go back to the disjointed sets. So when you have two sets, like let's say A and B, A and B, and A and B. Now these are supposed to be on top of each other, both of these, but I just wanted you to see that there are two. So A would be, A is disjointed with B. So that means like neither set A or B have anything in common. So let's say A has 1, 2, 3, 4, and B has B, C, D, and E. And then A, or this next section, it would be A and B might have some common elements. So there could be some commonality between the two sets in here. So let's say we have 1, 2, 3, 4, 5, and 6. So they both share in their sets the 2 and the 5. So that would mean that would be A and B. It says A and B might have some elements in common. And then on this A equals B, it would look like A, B is equal to A is equal to B. So A and B have exactly the same elements. And in this first column, it says A and B have no elements in common. So that's how you would kind of represent it in Venn diagrams. So like a complement of set A, let's say we're in here, we've got the 1, 2, 3, 4, 5, and 6. So in the complement of A, it would be in everything in this group right here that's not in A. So we would have like the 2, 3, or no, 2, 5, 3, and 6. That would be the complement of A. But you probably would put it in order, so it would be the 2, 3, 5, and 6. Because they're usually like in chronological order or numerical order. Okay. Any questions? Let me know. I kind of did it already, so that way it'd be easier and faster for us. So number 7, the shaded area outside A, represented by this A, is the universal set. So that's like everything that's part of it. Number 8, the example. How do we represent A minus B or B minus A? What is AUB minus C or A universal C minus A, etc.? So A minus B would be on this first one right here. We have the set A and set B, and then they have some shared common elements. But we're trying to find just the A that is not part of B as well. And then on the B minus A, it's the same thing. We have B. We want to find the B elements that aren't associated with A at all, that are not in that set of A. And then on the A universal B minus C, we have all of the ones that are part of A and B, but not part of C. So all the ones that are in purple, we have all of this and all of this, but because these parts of A and B are part of C, they're not included. So we're trying to find just the parts that are A and B. So that's kind of how you do that. Then down here is the same. We've got the AC version and minus B. So number 9, it says in the addition and subtraction of whole numbers, what is or are addends? I think that's how you pronounce it. Addends are numbers that are being added. So as far as the example, A plus B equals C, A and B are addends. So that's both numbers that are being added together. That is the addends. Now a sum is a result of two things being added together. So in this example, we have A plus B equals C. C is the sum. So it's the number that represents the two addends that are being added. The minuend is the number from which another number is to be subtracted. Example is A minus B equals C. A is the minuend. So it's the number that everything is being subtracted from. The subtrahend is the number that is to be subtracted. So in this one, it would be B, because A would be the minuend, B would be the subtrahend. And then the difference is the result of subtracting those two numbers. So it would be, the example would be A minus B equals C. So C is the difference. So if you have 5 minus 4 equals 1, 1 would be the difference. Okay, number 10. The operations addition and subtraction relate to each other in the form inverse, or like the opposites of each other. Number 11. Less than and greater than concepts. It says given whole numbers A and B, A is less than B, symbolized by A and the symbol for less than B. If and only if there is a whole number, it says K is greater than 0, such that A plus K equals B. B is greater than A, B is greater than A, whenever A is less than B. So that's just showing you what example of what a less than equation would be B is greater than A. So if B is greater than A whenever A is less than B. So it has to be one way or the other. Like one has to be less, the other has to be more. Okay, so this chart kind of got confusing to me, but I kind of got it now. What it is you fill it in for each column as it goes up. It also goes up by each row. What it is it's called the basic facts table for addition. So how it works, if it was actually connected together, like this would be a plus sign here. For every time that you go up, so you like say you have 0 plus 2, which is this is the 2, it will give you 2. Or if you have 2 plus 4, sorry, can't draw straight. So 2 plus 4 would be 6. We have the 4 would equal the 6. So that's kind of like the conclusion you should make. Now the pattern I found would be like something how it goes up diagonally, or it goes by this 90-degree line here. And it's like for every one you go up and over. So it's just a way of finding the facts on a table. So like if you have 8 plus 5 is 13. So you have the 8 on this side, and you go to the 5 and you bring your hands to the middle, and that gives you the 13. So that's kind of how that table works. Let's see what's next. Okay, properties of addition of whole numbers has 4 properties. Name, explain, and give examples. All right, so the addition. So the commutative property, it says 2 whole numbers may be added in any order without changing the sum. So that one example would be like the 7 plus 5 and 5 plus 7. So that means like it doesn't matter what order you add them in, it's always going to equal the same. So like if we have 10 plus 4 is the same as 4 plus 10. Same concept. And then we have associative property. So the sum of 3 numbers will be the same regardless of which 2 are added together first. So like say 7 plus 5, it could be 7 plus 3 plus 2. So this would be like 10 plus 2, or 7 plus 5. They both would give you 12. So 10 plus 2 is 12 and 7 plus 5 is 12. So they're both the same. Doesn't matter which one you add together first. For closure property, we have, it says addition of 2 whole numbers yields a whole number sum. An example would be 3 plus 1 equals 4. 4 is a real number, not negative. So like it doesn't give you a negative number. Like a positive and positive won't give you a negative. It'll always give you a positive. Identity would be the behavior of a specific whole number is such that adding it to another whole number doesn't affect the number. So that would be like 4 plus 0 equals 4. The 0 is like the has an identity itself, where if you add it to anything, it's still going to keep that first number the same. So it could be 10 plus 0 is 10. 1 plus 0 is 1. So that's like an example. All right, addition using different bases. Example, base 5 blocks would be 3 to the base of 5 plus 3 to the base of 5 equals 1 long and 1 single. Because if you're counting in base 5 and you add 3 plus 3, it would, like we have to carry over because there's no number 5 in base 5, so it would go from 3 to 4. So it would be 12 would be how you would like add it. So that would give you 1 in the tens place, and then you have 2 left over. So that's kind of how it works. So what she means is long is like this is a long one. These are singles. So 14, it says 4 to the base of 6 plus 3 to the base of 6. So same concept. You do 4 plus 3. It only goes up to 5. So it would be 1. It would go from 4 to 5. And then so you'd have to start carrying over. It would give you a remainder of 2. So then that 1 would come down. So you have like 12 base 6. So that is shown by the long one and then the short ones. So you have 1 long and 2 short. And the same thing over here, if you have like 1 long is like the tens place or and then the ones place. So all right, so we're going to do number 15. It says adding using base 10 manipulatives. Combine the two sets. So what this means is you've got, sorry, you have 200s, you have 6 tens, 1, 2, 3, 4, 5, 6, which 6 tens would be 60, 200s, and 1, 2, 3, 4, 5, 6, 7, 7 ones. So that would be 267 would be what you would have. And you're adding to it 131. So what it's doing, so it shows you have 200 plus 1 will give you like 3 100 blocks. And then you have the 1, oops, all of these combined would give you 1, 2, 3, 4, 5, 6, 7, 8, 9. See, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then you have the singles. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that would give you, if you add, like that's you combining both of those sets together, but they're not grouped where they should be. So then you come down here because you have like the singles is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when you do add 10 singles, that adds to a long one. Then a long one we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 long ones therefore change out and you add a 1,000. So that's where you get like the 400. Not 1,000, hundreds. So you get 400 is the total. So that's the same thing as saying like you have 7 plus 1 or 7 plus 3 is 10. 6 plus 1 is 7 plus 3 is 10. 2 plus 1 plus 1 is 4. So your answer would be 400. It's just showing you how to do it as if you were using blocks. Like say you had individual blocks, you'd stack them up. And then once it gets to that 10, then it's counted in the next column and there's nothing left in the ones. And then once there's 10 tens in the tens place, they would combine together and make the hundredth place. So you would have 400s, 0 tens, and 0 ones. It would just kind of move down the line. It's giving you a visual of seeing how it works by adding. Okay, so next we have the concept of subtraction. So A, subtraction may be thought of as the opposite of addition or the inverse of addition. I think that's the right answer. So B, the example would be 21 minus 18 is equal to what? You think of this problem as adding by asking yourself, what do I do? What do I add to blank to make 21? I know a lot of times when I'm subtracting, I start at the lower number and I count up to the higher number. So I'd say 18, 19, 20, 21. So the answer, 21 minus 18, would be the 3. So the question is, you can think of this problem as addition by asking yourself, what do I add to 18 to make 21? Therefore, 18 is one of the addends. Addends, I think that's how you say it. And 21 is the sum. So then we have C, the subtraction, can also be viewed as comparison model. Example, if Macaulay has 4 marbles and Jane has 9, how many more marbles does Jane have? So I did 9 minus 4 equals 5. All right, so then we have pictorial model of subtraction. I think what this is showing is just showing like 9 is the total and it's being broken apart by 4 and 5. So you got the whole and then part and part. So properties of subtraction. Does subtraction have an identity property? I said yes because, like, say you have 4 minus 0 is 4. So the 0, that specific number doesn't change the value of the first number. Just like when we were adding like 10 plus 0, it's still 10. And then B, it says, what about the commutative property? I said no, because if you change the order of the things being subtracted, it gives you a different meaning. So like say 5 minus 1 is 4, but then if you say 1 minus 5, that gives you a negative 4. So it doesn't have the same meaning. And then C, what about associative property? I said no, because that means like if you can move them around, the different numbers being divided or subtracted, and it would still give you the same outcome. But I said, like, if you say 5 minus 3 minus 2 equals 1, but then say you have 2 minus 3 minus 5, they're the same numbers, but that gives you negative 1 minus 5 is equal to negative 6. So the 1 is not equal to the negative 6. So that's my thought process on it. I think it's correct. But if you have any questions, just let me know. I will see you soon.